In question 1, we've got f of x being ax cubed plus 3x squared minus 8x plus 2. A is a constant. We are told that when we divide f of x by x minus 2, the remainder is 3, and we need to find the value of a. Well, if we divide f of x by x minus 2, we know that through the remainder theorem, the remainder is given by f of 2, so f of 2 is 3, which means that I will be substituting x with 2, so we get that 3 is equal to a times 2 to the power of 3 plus 3 times 2 to the power of 2 minus a times 2 plus 2, leading to 3 is equal to 8a plus 12 minus 16 plus 2. So I've got 3 is equal to 8a minus 2, so 5 is 8a, to conclude that the value of a is 5 over 8. In question 2, we need to find the coefficient of the term in x to the power of 7 in the binomial expansion of 3 over 8 plus 4x all raised to the power of 12. So you'll be using the binomial theorem here to obtain the expansion and therefore the coefficient of x to the power of 7. So we're looking at 3 over 8 plus 4x all raised to the power of 12. So if I consider the expansion here, the term I'm interested in is the term in x to the power of 7. So I've got 12 choose 7, and I've got 3 over 8 raised to the power of 5 times 4x raised to the power of 7. Well, notice that 5 plus 7 is 12. That's a rule in the binomial expansion. And also here I've got 12 choose 7. So the subscript here should agree with one of the two powers. Notice also that I could have written 12 choose 5, which is the same as 12 choose 7. And then I proceed with the rest of the expansion, so plus dot dot dot. Now I'm gonna get my calculator and evaluate this expression here. So we're looking at 12 choose 7 times 3 over 8 raised to the power of 5 times 4 to the power of 7. I get an answer of 96,228. So this is equal to dot 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 plus 96,228 x to the power of 7 plus dot dot dot. Remember, the question is asking for the coefficient, so the coefficient is just the number with the sign in front of x to the power of 7. So we conclude that the coefficient of x to the power of 7 is 96,228. In question 3, we've got the circle C centered at point A with coordinates 3, 5 and passing through the point B with coordinates 8, -7, and we need to determine an equation for C. Well, let's recall that a circle centered at alpha, beta and radius r has equation x minus alpha squared plus y minus beta squared is r squared. So to find the radius, I will simply consider the distance between A and B. So we're looking at 8 minus 3 squared plus the -7 minus 5 squared and all square rooted. This gives an answer of 13, and therefore we conclude that the equation of the circle is x minus 3 squared plus y minus 5 squared is equal to 13 squared. We then have that points M and N lie on C such that Mn is a chord of C. Well, we know that for Mn, this lies above the x-axis. It's parallel to the x-axis and has a length of 4 root 22. And we need to determine an equation for the line passing through points M and N. So I will start by drawing my circle here. It's centered at point A with coordinates 3, 5. So if I put points M and N and I join them with a straight line, this is a chord with a length of 4 root 22, which is parallel to the x-axis as instructed. Now if I join A with N, it's obviously a radius which has a length of 13, and then dropping the perpendicular from the center of the circle to MN. This means that we've got a right angle there, and we have just halved the length of MN. So this part here is 2 root 22, and I will call this height H. So if I just find the value of H, I know that from the y-coordinate of the center of the circle, I will proceed H units upwards to find the equation of this horizontal line. So let's apply Pythagoras here. We've got H squared plus 2 root 22 all squared is equal to 13 squared, leading to H squared plus 88 is 169. So H squared is equal to 81, which means that H is 9. And therefore, we conclude that the equation of line MN is y is 5 plus 9, so y is 14, because as we already explained, from the center of the circle, which has a y-coordinate of 5, I go 9 units up, because we know that we are parallel to the x-axis and we lie above the x-axis, and therefore this line here has equation y is equal to 14. In 4a, we need to sketch the curve with the equation y is a to the minus x plus 4, where a is greater than 1, and we need to show the coordinates of the point of intersection with the y-axis, as well as the equation of the asymptote to the curve. Well, we know that we're dealing with an exponential curve because x appears as an exponent, and we will start by considering y when x is 0 to find the cut on the y-axis. So when x is 0, y is a to the minus 0 plus 4, which is 1 plus 4, which gives me 5. So I've got the cut on the y-axis. Now to find the equation of the asymptote, there is a horizontal asymptote here. So I will consider what happens to y as x goes to infinity. So as x goes to infinity, a to the minus x will go to 0, because essentially a to the minus x, it's going to be 1 over a to the x, and this is growing larger and larger, so essentially we are tending to 0, and therefore we can see that y is tending to 4, and therefore the equation of the horizontal asymptote is y is equal to 4. This means I can proceed now into sketching the curve. We've got my x and y axis. I will start by drawing my horizontal asymptote with equation y is equal to 4. And we've got the curve coming down from left to right, cutting the y-axis at 5. So we've got this going down like that, and that's the graph of y is a to the minus x plus 4. We're then given a table of values for y is 3 to the minus a half x plus 4. We've got the x and the y values here, and we need to use a trapezium rule to approximate this integral here, giving our answer to two significant figures. Well, we know that if we're dealing with the trapezium rule, the integral can be approximated by a half times the height of the trapezia, which is the difference between two consecutive values of x, so it's 2.5. So a half times 2.5, and then the first and the last y values get counted once, so 13 plus 4.009 plus 2 times all intermediate values, so it's going to be 6.280 plus 4.577 plus 4.146 plus 4.037. If we carefully plug this on the calculator, we get an answer of 68.86125, which correct to two significant figures is 69. We are then asked to use the answer to part B to find an approximate value for this integral. So I will first start by rewriting the integral we just obtained. So from minus 4 up to 8.5, 3 to the minus a half x plus 4 dx, which I will decompose as the integral from minus 4 up to 8.5 of 3 to the minus a half x dx, plus the integral from minus 4 up to 8.5 of 4 dx. So the idea here is that the integral of the sum is the sum of the two integrals. We're trying to estimate this. We already have an estimate for the left-hand side, and I can obtain this analytically. So this leads to 68.86125 is equal to the integral from minus 4 up to 8.5 of 3 to the minus a half x dx plus 4x from minus 4 up to 8.5. So 68.86125 is the integral from minus 4 up to 8.5 of 3 to the minus a half x dx plus 4 times 8.5 minus 4 times negative 4, which leads to 68.86125 is the integral from minus 4 up to 8.5 of 3 to the minus a half x dx plus 50, and therefore this leads to 18.86125 to be the integral from minus 4 up to 8.5 of 3 to the minus a half x dx. And in II, we need to obtain an estimate for the sum of these two integrals here, where obviously the first one has already been established to be approximately 68.86125. And if we observe here what's happening, we can see that the 3 to the half x plus 4 corresponds to a reflection along the y-axis, because essentially we are multiplying all the x's by -1, so the minus a half x became a half x, so we are reflecting along the y-axis. And also we observe that the limits have been reversed and the signs have been changed, so we are still looking at exactly the same area because it has been reflected along the y-axis with the limits changed. So this is still 68.86125. So the sum of the two integrals is simply 68.86 plus 68.86, which correct to three significant figures is 138. In question 5i, we need to find the value of this summation here. So it's the sum from r equals 1 up to infinity of 6 times 0.25 to the power of r. Well, in such cases, it is wise to start by writing out the first few terms of this summation. So if I put r is 1, I get 6 times 0.25. If I put r to be 2, I get 6 times 0.25 squared, and then 6 times 0.25 raised to the power of 3. So this leads to 3 over 2 plus 3 over 8 plus 3 over 32 plus ... And we should be able to recognize this as a geometric sum starting at 3 over 2, and we keep multiplying by a quarter to get to the next term. Well, we know that in such case the sum to infinity, because we are adding an infinity of terms, is given by a over 1 minus r, and therefore in our case sum to infinity is given by 3 over 2 over 1 minus a quarter, which gives an answer of 2. In II, we've got another sequence starting at 3, defined recursively by un plus 1 being un minus 3 over un minus 2, and we need to show that this sequence is periodic. Well, starting with u1 is equal to 3, I'm going to use my calculator to generate the next term. So I press 3 and the equal sign, and then I'll be doing uns minus 3 over uns minus 2. So every time I press the equal sign, I generate the next term. So I press it for the first time, I get that u2 is equal to 0. Then again, I get u3 is equal to 3 over 2. And then again, u4 is equal to 3. And we observe here that u1 is equal to u4. So this means that the pattern will start again. So we're looking at a periodic sequence. So the only thing missing here is a conclusion. So we've got that since u4 is equal to u1, the sequence is periodic. In part B, we need to state the order of this sequence, and since we repeat every 3 terms, the answer is simply that the order is 3. In part C, we're asked to evaluate the sum of the first 70 terms here. So if we just write out the first terms here, we see that the sum from n equals 1 up to 70 of un is u1 plus u2 plus u3 up to u69 and then the u70. Now we see that from u1 up to u69, we are looking at 23 full periods of 3 terms. We've got this repetition, we said, of every 3 terms. So 23 periods here, and then the u70 is the new term, the first term of the new period. So that's going to be a 3 because the sequence starts with a 3. And therefore, this sum will be 23 times the 3 plus the 0 plus the 3 over 2, which are the 3 terms that make a period, they make a pattern, plus 3, and this gives an answer of 106.5. In 6a, we've got the logarithmic equation here, and we need to show that this leads to this cubic. So I will start by applying the rules of logarithms to collect all the logs on one side and then remove the logarithm. So we see that log of x plus 3 to the power of 2 base 4 plus log of x base 4 minus log of 4x plus 2 base 4 is equal to a half. Now we know that when we've got the sum of logarithms, then it's the logarithm of the product, whereas when we've got subtraction of logarithms, then it's the logarithm of the quotient. So all of this means that we've got log of x brackets x plus 3 squared over 4x plus 2 base 4 is equal to a half. I can now remove the logarithm by saying that x brackets x plus 3 squared over 4x plus 2 is equal to 4 to the power over half, and therefore we've got that x brackets x squared plus 6x plus 9 is equal to 2, which is the 4 to the half, times the 4x plus 2. I have cross multiplied here, and I can further expand the left hand side to get x cubed plus 6x squared plus 9x is equal to 8x plus 4, and therefore collecting everything on the left hand side will lead to x cubed plus 6x squared plus x minus 4 is equal to 0 as required. We're then given that the minus 1 is a root of the given equation, and we need to use algebra to find the other two roots of the equation. Well, we know that if minus 1 is a root, then x plus 1 must be a factor, so I can proceed with long division. So I'll divide the given cubic with x plus 1. I'll start by multiplying by x squared to get x cubed plus x squared, and if I deduct, I get 5x squared plus the x minus 4, so plus 5x here leading to 5x squared plus 5x, and I deduct again, leading to minus 4x minus 4, and this is minus 4 here, so minus 4x minus 4, again deducted, leaving me with a remainder of 0 as expected. So this means that the given cubic can be written in a factorized form as x plus 1 times x squared plus 5x minus 4 is equal to 0. So obviously one solution stems out of x plus 1 is 0, which is the x is minus 1 as expected, whereas the other two solutions will come out of the quadratic. I've got x squared plus 5x minus 4 is equal to 0, and I'll be using the quadratic formula to get the two solutions. So I get x is minus 5 plus minus 5 squared minus 4 times 1 times the negative 4 all square rooted divided by 2a, so 2 times 1, and this gives answers for x of minus 5 plus minus root 41 and all of it over 2. And finally, we're asked to solve the original logarithmic equation. Well, we know that the logarithm is well defined when its argument is positive, so I will start by pointing out that we need x plus 3 to be positive, greater than 0, and x to be greater than 0, and 4x plus 2 to be greater than 0. So this means we need x to be greater than negative 3, x to be greater than 0, 4x to be greater than negative 2, which means that x is greater than minus a half. And I observe that if x is greater than 0, if x is positive, then the other two inequalities are also satisfied. So out of the three possible candidates for a solution, we can see that the only one satisfying this condition here, that x is positive, is the minus 5 plus root 41 over 2, which is the only solution to the original logarithmic equation. In question 7, wheat is grown on a farm. In year 1, we've got 300 tons, and in year 12, it's 4,000 tons of wheat produced. Under model A, we're assuming that the wheat produced increased by the same amount, and we need to find the amount of wheat produced in year 4, giving our answer to the nearest 10 tons. Well, since we are told that we increase by the same amount, this means we're looking at an arithmetic sequence, and we know that the nth term of an arithmetic sequence is given by a plus n minus 1d, where a is the first term and d is the common difference. So we've got that u1 is 300, and that's the value of a, and u12 has been given to be 4,000, which is a, which we know is 300 plus n minus 1, so plus 12 minus 1 times d. So we get that 3,700 is equal to 11d, and therefore the value of d, the common difference of this sequence, is 3,700 over 11. I will now proceed in finding u4. So u4 is going to be a of 300 plus n minus 1, so 4 minus 1 times d, the 3,700 over 11. If I put this on the calculator, I get 1309.09 ... And since I've been asked to give my answer correct to the nearest 10 tons, I conclude that this is 1,310 tons. We then have a second model, it's model B, assuming that the amount now is increasing by the same percentage each year, and we need to find the amount produced in year 2 to the nearest 10 tons again. Well, if we are increasing by the same percentage, then we're surely looking at a geometric sequence, in which case we know that the nth term is given by AR to the n minus 1. So once more, we've got that U1 is 300, which is equal to A, and U12 is equal to 4,000, which is equal to A of 300 times R to the 12 minus 1. So we get that 4,000 over 300 is equal to R to the power of 11. Now the two zeros with the two zeros will cancel out, so we can conclude that the 11th root of 40 over 3 is the value of R, and therefore if I'm trying to calculate U2, it's gonna be A of 300 times R, which is the 11th root of 40 over 3 raised to the power of 2 minus 1. This gives an answer of 379.654 ... which rounds to 380 tons, correct to the nearest 10 tons. And finally, in part C, we need to calculate the difference between the total amounts predicted by the two models for the first 12 years. Well, we have established that we are looking at an arithmetic sequence. The first term and the common difference are here, and the formula for the sum of the first n terms is n over 2 2a plus n minus 1d, whereas for the geometric sequence, the corresponding formula is a1 minus r to the n over 1 minus r. So for the arithmetic progression, S12 is going to be 12 over 2 times 2 times 300 plus 12 minus 1 times the 3,700 over 11. I will plug this on the calculator, giving an answer of 25,800, whereas for the geometric sequence model, S12 is going to be 300 times 1 minus the 11th root of 40 over 3 raised to the power of 12 over 1 minus the 11th root of 40 over 3. Well, this gives an answer of 17,935.20 ... So we've been asked to give the difference between the two models, so I will simply deduct one from the other. So 25,800 minus the 17,935.20 ... gives an answer of 7,864.796, which rounds to 7,860 tons, correct to the nearest 10 tons. Do notice, however, that the mark scheme here is also allowing 7870. In question 8, we are asked to use a counterexample to show that the statement that n squared plus 3n plus 1 is prime for all n in the naturals is false. Well, the natural numbers are the positive integers, and we need to provide a particular example for a value of n that yields a composite number, a number which is not prime here. So what I will do is I will automate the whole process on my calculator to check for different values of n immediately. So I press menu, it's option 9. F of x here is x squared plus 3x plus 1. I will leave the g of x empty. I will go from 1 to 5. Remember that the n must be a natural number, a positive integer. So I'll be trying 1, 2, 3, 4, 5 immediately. So these are the results here. All of these are primes. So I will go here and put a 6 to evaluate this when x is 6, which is the corresponding for n being 6. And I get the value of 55, which is 5 times 11. So we have found a number which is not prime. So only thing missing is for me to state exactly what happened here. So when n is 6, we get that 6 squared plus 3 times 6 plus 1 is 55, which is 5 times 11, which is not prime. And therefore, the only thing missing is a full conclusion that the given statement is false. In II, we need to use algebra to prove by exhaustion that for all naturals, n squared minus 2 is not a multiple of 4. So I will start by considering the case that n is even. So if we consider n is 2k for some k in the integers, we've got that n squared minus 2 is 2k all squared minus 2, which is 4k squared minus 2. which is obviously 2 less than a multiple of 4. So for the case that n is even, we are not looking at a multiple of 4. We then proceed by considering the case that n is odd. So we consider n is 2k plus 1 for some k in the integers. So n squared minus 2, it's going to be 2k plus 1 squared minus 2, which I will expand to get 4k squared plus 4k plus 1 minus 2. I will factor out the 4, so 4 brackets k squared plus k minus 1, which I recognize as 1 less than a multiple of 4, so again not a multiple of 4. So this way I have conducted an exhaustive search because I have divided all the integers into even and odd, and therefore the only thing missing is an overall conclusion that for all n in the naturals, n squared minus 2 is not a multiple of 4. In question 9, part I, we need to solve for x between 0 and 360, sin x tan x is 5, giving our answers to 1dp. So starting with the given equation, the first thing to do is write tan x as sin x over cos x. So we are looking at sin x times sin x cos x is 5. I will cross multiply by cos x to get sin squared x is equal to 5 cos x. And we know that sine squared plus cos squared is 1. So on the left-hand side, we've got 1 minus cos squared x is equal to 5 cos x. And if I collect everything on the right-hand side, we get that 0 is cos squared x plus 5 cos x minus 1. So we're looking at a quadratic in cos. I can proceed with the quadratic formula. So we've got that cos of x is equal to minus 5 plus minus 5 squared minus 4 times 1 times negative 1 and all square root over 2 times 1. If I put this on the calculator, I get a result of minus 5 plus minus root 29 over 2. And therefore, we conclude that cos x is either minus 5 plus root 29 over 2 or cos of x is equal to minus 5 minus root 29 over 2. Well, for this second solution, numerically it's minus 5.19 dot dot dot, and we know that the cosine of x attains values between minus 1 and 1, and therefore we say that we reject any solution this side because this is not valid, and the only solutions will come out of cos x being minus 5 plus root 29 over 2. So we'll start by finding the principal value. So the PV is given by shift cos of minus 5 plus root 29 over 2. So we'll go on the calculator here, shift cos, and we've got minus 5 plus root of 29 over 2. If I press the equal sign, I get a value of 78.896. So let me write this down, 78.896 dot dot dot, which I will be storing on A so that I maintain full accuracy. And we know that all solutions when dealing with a cosine equation come out of plus minus the PV, so plus minus A plus 360k. So I'm gonna press menu, it's option 9, table. My f of x is a plus 360x, and my g of x is minus a plus 360x. So all I'm doing is I'm automating the whole process of generating the solutions between 0 and 360. So I will start at -2, say, go up to 2, and we will see what kind of solutions we get. It's crucial to have the step being 1. So essentially we are substituting different values for k here, and we can see that between 0 and 360, one solution is a 78.9. So let me write this down. X is 78.9, and another solution would be the 281.1. So a total of 2 solutions in the range of 0 to 360. In II, we're given a sketch of part of the curve with this equation here. We are told that there is a constant and theta is in radians. And given that the y-coordinate of P is 7, we need to state the value of A. So what we are looking at here is a series of transformations. So let's see what's happening here. This a here means that we're multiplying the y by a, and the plus 2 means that we are adding 2 to y. So we first multiply y by a, and then we add 2 to y. And looking at 2 theta minus 3 pi over 8, we said that anything that goes along with theta goes along the direction of theta, the horizontal direction, contrary to what we expect. So in this case, we go everything the other way around, so we even violate the order of operations, even though we are inclined in first dividing by 2 and then adding the 3 pi over 8, because we are doing everything in reverse. We first add 3 pi over 8 to theta, and then we divide theta by 2. In any case, knowing that the y-coordinate of P, and P, as you can see, is a maximum point, is 7, we knew that in the original graph of sine, the maximum had a value of 1. So I will take this 1, multiply by a, and add 2, and I get the result of 7, which means that a is equal to 5. In part B, we're asked to find the exact coordinates of point Q, so I will start by recalling the graph of sine theta. We've got cuts on the horizontal at pi and 2 pi, and we've got a minimum at 3 pi over 2 comma negative 1. If we look at the diagram given here, Q is the minimum in this transformed graph. So I will take the x-coordinate of 3 pi over 2 and apply the exact transformations we have identified here. So I will add 3 pi over 8 to the value of theta and then divide theta by 2. So what we're looking at is 3 pi over 2. So I'm adding the 3 pi over 8 and then multiplying this by a half. This gives a value of 15 pi over 16. And for the y-coordinate, it was originally at negative 1. This will be multiplied by the value of a, which is 5. And then I will add 2. And this gives an answer of negative 3. And therefore, we conclude that the point Q has coordinates 15 pi over 16, comma negative 3. In part C, we need to find the value of theta at R. This is the point R here. This is the equation of the graph. Well, we know that A has a value of 5. So essentially, we can start by noting that at point R, the y-coordinate is 0. So essentially, we're trying to solve 5 sine of 2 theta minus 3 pi over 8 plus 2 is equal to 0. So this means that 5 sine of 2 theta minus 3 pi over 8 is equal to negative 2, and therefore sine of 2 theta minus 3 pi over 8 is minus 2 over 5. I will proceed by finding the principal value, which is given by shift sine of minus 2 over 5, which gives an answer of minus 0.4115 dot dot dot. So if I go on my calculator here, shift sine of minus 2 over 5, I'm in radian mode, this is the minus 0.4115, and I will store it on A to be used later. So I've stored this on A, I make a note, and I proceed. When I'm solving a trigonometric equation involving sine, we know that one solution comes out of 2 theta minus 3 pi over 8 is equal to the PV plus 2 pi k, and the second solution is given by 2 theta minus 3 pi over 8 is equal to pi minus the PV of A plus 2 pi k. So I will be solving for theta. We've got 2 theta is equal to A plus 3 pi over 8 plus 2 pi k, and then I will divide by 2. So theta is a half times A plus 3 pi over 8 plus 2 pi k, whereas for the second equation we get 2 theta is pi minus A plus 3 pi over 8 plus 2 pi k, and once again I will divide by 2 to get theta is a half, and I've got pi minus A plus 3 pi over 8 plus 2 pi k, and I will proceed on my calculator to generate all solutions. So again, menu 9, my f of x is a half of A, so alpha A, plus 3 pi over 8 plus the 2 pi x, so 2 pi x, and I close the bracket, whereas g of x will be the a half, and then we've got pi minus the a plus the 3 pi over 8 plus the 2 pi x. So I close the bracket. I could start at -2 and I go up to 5, say step is 1. I will be writing down all positive solutions, and as we can see, the first positive solution is theta is 0.383, and then we've got the 2.366. Well, if we are careful here, the point R is the fourth cut on the horizontal axis, so 1, 2, 3, 4. So I want the fourth solution. So the third one is 3.525, and the fourth one, which is what we're trying to find, is 5.507, so 5.51 to 3 significant figures, and therefore we conclude that theta is 5.51. In question 10, we're given a sketch of the curve with this equation here. We are told that P is the only stationary point, and you need to use calculus to show that the x-coordinate of P is 9. So calculus means differentiation. Let me start by writing this as y is a half x squared plus 1,458 over x to the 3 over 2 minus 74, which can be written in index form as a half x squared plus 1,458 x to the minus 3 over 2 minus 74, and we proceed in finding the derivative. So dy dx will be a half times the 2x, so I get the power down and I deduct 1 from the power, plus 1,458 times minus 3 over 2 x to the minus 5 over 2, and the minus 74 vanishes because it's a constant. So this is equal to x minus 2,187 over x to the 5 over 2, and we know that for a stationary point the dy dx is 0. So we have x is 2,187 over x to the 5 over 2. I will cross multiply to get x to the 7 over 2 is 2,187, which means that x is 2,187 to the power of 2 over 7, which gives a value of 9 as required. Alternatively, once you have found the expression for dy dx, you could have evaluated dy dx at x is 9 and show that this leads to 0, therefore concluding that the x-coordinate of P is 9. In part B, we need to use algebraic integration to determine the exact area of the shaded region R. It's the region here. Well, we already know that the x-coordinate of point P is 9, so it makes sense to proceed in finding the y-coordinate of P. So that means that when x is equal to 9, we get that y is equal to a half times 9 to the power of 2 plus 1,458 over 9 cubed and square rooted minus 74, which gives a value for y of 41 over 2. So let me write down that this line here has equation y is 41 over 2. This means that I can find R by integration. R is the area enclosed above by the curve, below by the straight line, and the limits are 4 and 9. So R is the integral from 4 up to 9 of a half x squared plus 1,458 x to the minus 3 over 2 minus 74 minus 41 over 2 dx. Before I proceed with integrating, I will simplify the expression. So this is the integral from 4 up to 9 of a half x squared plus 1,458 x to the minus 3 over 2 minus 189 over 2. And we know that in integration we increase the power by 1 and we divide by the new power. So this leads to a half, and it's x cubed over 3 plus 1,458 x to the minus a half over minus a half minus 189x over 2, and my limits are 4 and 9 respectively. I will simplify this. This is x cubed over 6 minus 2916x to the minus a half minus 189x over 2 with the limits of 4 and 9. So I will substitute the upper limit and the lower limit and deduct. This means we're looking at 9 cubed over 6 minus 2916 times 9 to the minus a half minus 189 times 9 over 2. This is the upper limit substituted minus the lower limit of 4 cubed over 6 minus 2916 times 4 to the minus a half minus 189 times 4 over 2. So I'm gonna go on my calculator. I will press 9 and store it on my answer key, and then I will do ans cubed over 6. So I'm trying to evaluate the upper limit here, minus 2916 ans to the minus a half. That's it there. And then I've got minus 189 ans over 2. So if I press the equal button, I get minus 1701. And then I'm going to do the same for the lower limit, but I will simply do 4 equals, and then I will press the up button here to obtain the expression I had before. Just press the equal sign, and I get the result of minus 5476 over 3. If I deduct one from the other, I get the final result of 373 over 3 squared units.